Hi Aaron, today we're gonna solve the LeetCode problem 528 random pick with width. So I have been thinking about this problem for a while. I just didn't have time to record the video. So today I finally got some time and let's read the description. You're given a zero-index array of positive integers w where wi describes the weight of i's index. You need to implement the function pickindex, which randomly picks an index in the range from 0 to w the length -1 inclusive, and returns it. The probability of picking an index I is wi divided by sum w. So for example, if w is equal to 1, 3, the probability of picking index 0 is 1 divided by 4, and the probability of picking index 1 is 3 divided by 4. So this problem is quite clear. We're gonna do the random pick with weight problem. So we can think about something like if we want to throw a store and we're gonna have a lot of points. So basically if we look at this example, so we have the array is 1, 3, 2, 0. If we think about we have a line and we wanted to throw a stone, and therefore the stone will drop in some points in this line. So basically that's kind of problem it is, and we will find accordingly what kind of index the stone eventually dropped. So we immediately think about the prefix sum problem. So basically we will first create our prefix sum array. So if we record the knowledge we have learned before, so basically for prefix sum array, we're gonna let the length of it is equal to original array's length plus 1. And if we are thinking about the difference array problem, it's gonna be same. So for the prefix sum array, we're gonna create it, and the length will equal to double the length plus 1, and we will calculate the prefix sum array. So after we have got our prefix sum array, we're gonna random pick an index. So here we're gonna use the random class. So random is a class that in Java that's part of the Java util package. So it's useful for generating random numbers, and it provided a variety of methods. So we're gonna have our rand is equal to new random. So this is creating an instance here, and we're gonna use rand.next int, and we will give it the pre-sum n-1. So this is the number. So if we are still using the 1, 3, 2 to 1 array example, this is the last element in the pre-sum array, so it can be 7. So let's see, 1, 3, 2, 1. We have last element is 7, and we're gonna notice here we wanna plus 1. So why is that? So basically we wanna choose if we think about the next int, it's gonna be random. The next int is gonna be from 0 to 7, and the 7 is not included. And if we plus 1, it's gonna randomly help us pick a number from 1 to 7, and the 1 and the 7 are both inclusive. So that's the result we want to get. So therefore in the range, if we want to pick, we can pick 1, and for the second one we can pick 2, 3, 4, and that's 3 points. and for the 5, 6, it's gonna have 2 points, and then 7 is a extra 1 point. So therefore, we're gonna plus 1 here, and then use a binary search. So why we want to use binary search here? So to be honest, I feel like if we are not using binary search here, it's okay. We just use a linear search. We can solve this problem still in big O of n time complexity is okay. But since technique, this is kind of, we have a target and we have array, and we wanted to find the index of elements in the array that is larger than target, and we wanted to find the first one. So it's the smaller element in array that is larger than target. Basically, it's just like find the left boundary. We have learned a lot of things about that in binary search before, so we're gonna use a binary search. And therefore, if we were using binary search, the time complexity of peg index gonna be big O of log n instead of big O of n. So we have successfully reduced the time complexity. And for the constructor, of course, the time complexity will be big O of n, but it's okay. We just want to, since we are using the peg index frequently, we're gonna to reduce the time complexity of that, and the space complexity solution is big O of n. So